In this lesson, we're going to be doing just a very, very brief introduction to the graphs of sine and cosine. So there's a lot more that you can and will eventually learn about sine and cosine graphs if you take a pre-calculus course, but here we're just going to kind of scratch the surface. Y equals sine x and y equals cosine x are our parent graphs. Both of these are part of a category called sinusoids. So sine, sinusoid, cosine. And these are the only two sinusoids that you're going to learn. So no other equation other than these two is going to fall into that category of sinusoids. A sinusoid is a function whose values repeat based on positions of a point that moves around the circle. Now, here's what always happens with these is that people just look at this part and they say, oh, anything whose values repeat is a sinusoid. And that's not true. It has to be values that repeat based on positions of a point moving around the circle. And the circle that we'd be moving around in this case would be the unit circle. So I'm just going to draw just a little bit of the unit circle here. And on the unit circle, remember that the radius is 1. So if you look at 0 or 2 pi, the ordered pair is 1, 0. Here it's 0, 1. Remember that halfway in at 45 degrees, the ordered pair is radical 2 over 2 for both. Over here, we have negative 1, 0. Here we have 0, negative 1. Over here, we have negative radical 2 over 2, radical 2 over 2, so on and so forth. So what we're going to do is we're going to set up coordinate planes to look at our parent graphs because you are going to need to be able to identify each of the sine and cosine graphs and a couple of their key features. So if we look at our horizontal axis and instead of labeling it 1, 2, 3, 4, we're actually going to label it according to the quadrants. So we're going to make this pi over 2, pi, 3 pi over 2, and 2 pi. And then same idea over here, except obviously we're going in the negative direction on that side. We're going to keep this one and negative 1. Now, if I choose my theta, my x value, if I want to do sine at 0, remember that we learned in the last lesson that in the ordered pair, the sine value is the y. So at 0, the y value is 0. So point right here, 0, 0. When I make my x pi over 2, pi over 2 is at 90 degrees. The y value there is 1. So pi over 2 is the x. That means the y is 1. When I go to pi, which lands here, the y value back to 0. At 3 pi over 2, it's negative 1. And then at 2 pi, I'm back to 0 again. Now, here's what happens. If I keep counting, like if I keep going to the right by pi over 2's, my values are now just going to repeat those exact points because we're moving around a circle. That's why this is called a sinusoid, because we take 5 points. 5 points equals 1 period or cycle of that sinusoid. So all that's going to happen after this 2 pi is it's going to do the same things. Up, middle, down, middle. Up, middle, down, middle. All of those over and over again. If I go in the negative direction, same thing happens. If I go negative 90 or negative pi over 2, I get negative 1. Negative pi is at 0. Negative 3 pi over 2 at 1. And then back to 0. So what I have here is my parent graph for sine. And your sinusoid graphs always look like this. They always have a hill followed by an equal-sized valley, followed by a hill, followed by an equal-sized valley. You're never going to see two valleys in a row or two hills in a row on a sinusoid, and you're not going to see different peaks and valleys. The sine curve is an odd function because it is symmetric about the origin. So we would call that an odd function. Cosine, if I do the exact same thing that I did for sine, except knowing that cosine is the x, when I have, and I'm only going to label some of these this time, just for the sake of saving time, all the labels are the same as they were on sine x. At pi over 2, my cosine, or at 0, sorry, my cosine value is 1. So it doesn't start in the same place. At pi over 2, it's 0. At pi, it's -1. Then back to 0, and then back to 1. Oops. 1, 2, 3, 4, 5 points for one full period of the graph or one full cycle. And the pattern would continue on the other side because we're just moving around the circle. So, whoa, sometimes it's hard to use these pens. I'm so sorry. That did not connect very well. There we go. So again, equal size hill and valley. Valley always follows a hill and vice versa. The cosine curve is an even function because it's symmetric about the y-axis. I could fold it here and it would line up on top of itself. Valleys in the same spot, hills in the same spot. So sine is odd, cosine is even. Key features of both of these parent graphs. Because it takes 5 points to get one full period, 1, 2, 3, 4, 5, we call the period of both of these graphs 2 pi. What that means is that's the horizontal distance, the length of one full cycle. So when I'm saying length, I'm meaning from here to here. That's the period. The amplitude is the distance from the middle points to the top points, or it could also be distance from the middle to the bottom. So amplitude is going to be right here, which means that in this case, it happens to be 1. So 1 is our amplitude on both of these. Again, see it's 1 here as well. The midline is at y equals 0. That's the middle where all of the hills and valleys come back to before they change. So y equals 0 or the x-axis. Domain. For my x values, I put arrows here for a reason. I can just keep going around the circle as many times as I want. If I want to go in the negative direction, I can just keep going around the circle. So that means that the domain is all real numbers. The range, however, is not all real numbers. If you look at the y values, the lowest y value is -1. The highest y value is +1 on both of them. So the only other thing you're going to have to be able to do is some mild transforming here. So when I have a sine bx, meaning I've got a number multiplied in front or a number multiplied in front of my x, a is going to be my amplitude. So it's going to change how tall my sinusoid is. Period changes the length of the cycle, and it is always 2 pi divided by b. So what we're going to be working with here instead of the parent graph is y equals 3x. So we've got a transformation here. First thing I would suggest doing is writing out the values of a and b. So in this case, I can see that a is 3. That's the number in front of sine. B would be what's multiplied times the x. If nothing is written, then it's understood to be a 1. So B is 1. So amplitude is A. So that's pretty easy. I would say, okay, my amplitude is 3, which means it's going to be 3 units from the middle to the top and 3 units from the middle to the bottom. The period is going to be 2 pi divided by b, which is 1, which is 2 pi, which means it's going to take the same amount of horizontal length to get 1 full cycle as it did on the parent graphs. Domain. My domain, let me give you a hint on these sine and cosine, it's never changing. The domain on all of these sinusoids is always all real numbers. So don't pick anything else for domain. Range, however, does change based on the amplitude, because if I've got my middle here and I go 3 units up for the amplitude and 3 units down, that means I'm going from -3 to +3, and that would be my range. So range is going to change based on the A value. Period might change based on the B value. In this case, it didn't because it's 1, and that's how we do those types of transformations. You're not going to have to do any type of shifting or any of that because, as I said at the beginning, this is just a very brief introduction. And that should wrap us up. So I think we're good. Make sure you ask if you have questions.